The University of New South Wales ECHO satellite has today been deployed from the International Space Station. It's the first Australian satellite in 15 years to be deployed into space. For more, we're joined by UNSW-EC0 project leader Elias Aboutanois. Thanks so much for coming into the studio. Tell us how important this satellite is.
Well, good evening, Rachel. The satellite is very, very important. It's one of 3 Australian satellites. So in the first time in 15 years, since FedSat in 2002, Australia has satellites in space. I mean, this is a momentous occasion.
And what will it be looking at or studying?
So the satellite is part of the QB50 mission. It's a European mission led mission to study the thermosphere or the ionosphere, which is the layer of the atmosphere between 100 kilometers and 1,000 kilometers. And the lower part of it hasn't been really well studied before. And we're part of a constellation that includes about 28 nations.
And why is that level of the atmosphere important? Why do we need to know more about it?
Well, it's important because it affects us in a number of ways. It affects the way we do things. So it affects our weather on Earth. It affects our satellites. So satellites experience drag. There's still atmosphere up there, and we need to be able to predict their orbits. And it affects the way we communicate with satellites. It affects our GPS, for example. So as GPS signals come down to the Earth, this layer acts like a lens and distorts them, and that affects our accuracy.
So the satellite was launched, as I said, just this afternoon, but it hasn't really gone according to plan just yet.
Well, yeah, it's not unexpected. The satellite was actually launched on the 19th of April. It's been since on the International Space Station. This afternoon at 3:25 p.m. it was deployed from the International Space Station, and at 4:21 p.m. we started seeing it. We see it for about 10 minutes, a bit less than that. We tried to establish contact with it. We haven't succeeded yet, but that's not unexpected. Like I said, we've handed the satellite over more than 8 months ago, and a lot would have happened since. So we're going to go through a troubleshooting phase.
So when will be your next opportunity to try to make contact with it?
So the next opportunity will be at 5 a.m. tomorrow in France. We've got a collaboration with a number of Earth stations. One of them is in Strasbourg in France. And that's at 5 a.m. our time. Then we will have there will be another opportunity for France as well, an hour and a half later. So this thing orbits the Earth once every hour and a half. It goes a full circle.
Okay.
And we will see it again at 7:15. That'll be the next opportunity here in Sydney.
Okay, and tell us about the work, I guess, to create this satellite, and as you say, 8 months ago, hand it over.
Well, it's been 5 years in the making. It's
wow.
Satellites usually are understood to be something that big companies and more traditionally governments build. We're a university team. Like I said, we're one of 3 universities in Australia. So this is really a game changer. It's 5 years. It's been 5 years in the making. We've succeeded. We've handed it over to NASA. They've launched it for us. The project has involved students. It's involved a big team at the university, including postdocs and students and other staff.
And obviously the work isn't over yet, because once you get that communication up and running, you'll be, I guess, looking at what sort of findings it brings back for a while yet.
Yes, so the satellite will be up there for about a year. And during that time, it will be compiling data on the thermosphere as part of the QB50 mission. But beside that, we've got our own experiments as well. We've got a GPS-based experiment to look at the ground. That's called reflectometry. We've got one to study the lower atmosphere, basically the layer that we live in. And the structure itself is 3D printed. That's an experiment.
And how did you go about printing a satellite using 3D?
So the structure normally is an aluminium machined structure. That takes time. They're expensive. So what we've done is we've used a thermoplastic. It's really low cost solution. It's rapidly manufactured, and we've coated it with nickel for conductivity. So that means it can conduct electricity. So now it's in space. We're going to see how it behaves. Okay. And if that's successful, that's a really big finding.
Absolutely. Well, congratulations to you and the team, and hopefully we'll be able to get a bit of feedback from you in a few months to see how it's all going. Thanks a lot.
Thank you very much.